Assalamu alaikum wa rahmatullahi wa barakatuh. Grade 10 students will continue with our revision of Unit 1, Forces and Motion. Our topics today, inshallah, we will revise Section 1, Motion in One Dimension, Newton's first law, Newton's second and third law. We'll start with the force. What do I mean by a force in a simple term? It's a push or apply. Push or pull, or I can say a force is an action exerted on an object which may change the object's state of rest or motion. Here I can throw this ball, so this is what? Push. I can catch the ball, so this is pull. So it's in a simple term, push or pull. Forces can cause acceleration. What is the SI unit of forces in Newton? N. I have other units other than SI units, which is pound, equals to 4.4 in Newton. How can I measure the forces? By the spring scale. I have type of forces, and you need to know these type of forces, distinguish between them. Applied force, it's push or pull. I have spring force. Whenever you have a spring, you will have this restoring force that tries to bring the spring back to its equilibrium position. If I stretch or compress the spring force tries to bring it back to its equilibrium position. I have air resistance. Whenever here skydiver jumps from aeroplane, so he will goes down because of the gravity. We have here gravity down. What will push him up? Once he opens his parachute, I have air resistance up, pushing him up. Friction force, and this force is really important. It prevents us from slipping or skidding on the floor. Normal force, and it is usually the force applied by a surface. If any object touches a surface, this force is push the object up, and it's always perpendicular to the surface. Not all the time against the gravity, force of the gravity, but all the time it's perpendicular to the surface. Perpendicular means 90 degrees, Fn. Spring force is F, and if applied, FAP. These we call them contact forces. Why? Because there is direct contact between the object, like this one, the object, and the force. I have non-contact or field forces. So, like what? These non-contact. There is no direct contact between these forces and the object, like magnet. Magnet always attract anything that's made of iron. Magnet, north and south, they attract each other. South and north attract. North and north repel each other. Electric force, like if I have positive charge and negative charge, they attract, and this we will study it inshallah when we study Coulomb's law. Magnetic force, we will study it in grade 12 once we study magnetism. Negative and negative, they repel. Positive and positive, they repel. Gravitational force, and we will focus on this force here in this unit. It's always toward the ground. Anything, if you, like an apple, if you leave it, the apple will fall down because of the gravity. Tension force, whenever you have a rope or string, like you have for example, here, it could be a lamp, a light, and is hanged in the ceiling with a string. So here I have a tension force, Ft. And this is Fg, gravitational force. Normal force, Fn. Friction force, we will study it in more detail. We have two types of friction. Here in your copybook, you have the definition of each of one of these forces and the direction. This is really important to distinguish between these forces. Know the definition and the direction. Normal force. What is a normal force? As we said, it's a contact force exerted by a surface. So if you have here, for example, a TV on a table, the TV attached the table. I have two forces acting on the TV. The TV is not moving. This force down, we call it the gravity. The weight is always down. And the table will push the TV up. We call it Fn. This is, we call it free body diagram. So free body diagram, you have an object. You go to the object. From the center of the object, you draw all the forces acting on the object. Sometimes I don't need to draw the object. I can draw the object as a box or circle to represent the object. What is the direction of this force? Perpendicular and away from the surface. So this is the surface, is perpendicular to the surface. Is it always opposite to the gravitational force? No, not always opposite, because if you have inclined surface with an angle with the horizontal. In this case, gravity down. Here is the surface. Here is the surface. Normal to the surface will be Fn. You see, it's not in the same. Is not in the same line as the gravity. So not always opposite to the direction of the force of the gravity. It has another name, which is the reaction force. React to applied force. Friction force. Friction is always opposite to the direction of motion. If you have an object, and this is the direction of motion or direction of acceleration, the object is moving, you push this object, push, we said, is applied force. The object will move in this direction, opposite to the direction of motion, I have a friction. So I have two types of friction, static, Fs, and kinetic or dynamic friction, Fk. What is the difference between them? Static is the force exerted on one surface by another when there is no motion. No motion. I keep applying a force on my table. The table is not moving. Why? Because of static friction. Once my table starts to move, the friction will drop, and we'll have, in this case, kinetic friction. Here, the applied force and the friction force. As the applied force increased, the friction force always also increasing. They need to drop to friction, kinetic friction. So kinetic is the force exerted on the surface by another when two surfaces rub against each other. Here I have movement. Both are moving. I have coefficient of static friction is a number. It doesn't have unit. And it describes the ability of the surface to resist the sliding at rest. And here, the ability of the surface to resist the motion. Of each of these, it's a number. Usually is less than 1, this number. And depends also on the surface. Whether the surface is smooth, rough. It depends also on the surface. This activity, we did it on FIT. I will revise it very quickly with you. If you go to FIT simulation, here I can apply force. You see at the direction of the friction force. As I increase the applied force, what will happen to the friction force is increasing till the object starts to move. In this case, the type of friction is kinetic. Applied force, as you notice to the right, is 133, is greater than the friction force, which is 94. So the object starts to move here, and the type of friction is kinetic friction. If I draw a relationship between the friction and the normal force, I will get straight line. The slope of this straight line, as we did in the lab, equal the coefficient of static friction, whether static or kinetic. Then we studied Newton's first law. Newton's first law is the law of balance or equilibrium. What says Newton's first law? An object at rest will remain at rest. Like I have my table is not moving. It stays at rest unless I apply the force on it. Object in motion, it will stay in motion with same speed unless the object experiences a net external force. In other words, F net equals 0. This is in Newton's second law, first law. So in Newton's first law, I can write it in a mathematical way. F net equals 0, or summation of forces acting on the object equals 0. I have two cases to apply Newton's first law. When do I know my problem is in Newton's first law? Either the object, it will tell me in the question, the object is at rest, it means it's not moving, velocity 0, no acceleration, or it's moving but with constant speed or constant velocity. The word constant, I don't have acceleration, no change, because acceleration is a change in velocity divided by change in time. Since the velocity is the same all the time, the object moves with the same velocity, no acceleration. So it's in Newton's first law. This represents also the equilibrium or balanced. All the forces are balanced, whether they have forces to the right or to the left, are balanced or equal. So Newton's first law describes objects in equilibrium. If I want to solve any question related to Newton's first or second law, these are the steps I need to follow. First, I have to write the given, check the units. I have to make sure all the units are consistent. Draw free body diagram, determine the direction of motion or the acceleration. Forces that are in the same direction of motion are positive. Forces in the opposite direction, negative. We have to do X and Y component for these forces. Determine after that whether I apply Newton first or Newton second. If in Newton first, summation of forces will equal 0, it means this is balance. That means summation of forces equals 0. All forces on the right, it means on x-axis, right of the x-axis will equal all forces to the left of x-axis. Similarly, if I have forces in y direction, not x direction, if I have forces in y direction, that means all the forces up will equal all the forces down y-axis. Let's take example. Here I have a Thomas sits on a small rug on a polished wooden floor. The coefficient of static friction, the kinetic friction between the rug and the slippery wooden is, so here, this one is mu k. I can write the given on the problem itself. Thomas weight, so weight, this is Fg, 650. The horizontal floor needed, I need to find the horizontal floor, the applied force. Free body diagram. An object, I can draw it as small box. This represents Thomas and the rug. I have applied force. Opposite to this applied force, I have a friction and it's kinetic friction. Constant speed, it means no acceleration. If the object will move, it will move in this direction. This is direction of motion, but I don't have acceleration, it's 0. What else do I have? I have weight is always down, and the weight of Thomas and the rug is 650 in Newton. And up, I have a normal force. After, let's go here. I draw the free body diagram. I determine the direction of motion. What should I do next? I know it's in Newton's first law because constant speed, so I need to apply Newton's first law. Forces in direction of motion. Positive, I don't need this one because actually it's in Newton's first law. All the forces to the right equal to the forces to the left. So here I'll make x and y. All the forces up will equal to the forces down, which is 650 Newton. All the forces to the right, which is applied force, will equal to the Fk. Fk, it's mu k times Fn. Then substitute. Applied force, I don't know. If applied, I don't know. I need actually to find it out. Mu k is 0.12. Fn 650, and if you calculate this one, you should get 78 in Newton. That's it. I'll continue with you, inshallah, second video for Newton, second law.